So here we have to evaluate two definite integrals, right? So just we'll first look at this part. Okay, this is 1 to log 2n and this function. So what we'll do, let's say t cube is equal to 2 to the power x minus 1, right? So that means if I differentiate both the sides with t, 3t square dt upon dx is equal to, the differential of this is going to be 2 to the power x ln 2, right? So from here we have dx is equal to 3t square dt upon 2 to the power x ln 2, right? Also 2 to the power x cube is this. So this thing here is going to be t cube to the power 1 by 3, that is t only, right? For dx I'll write this. So 3t square dt upon 2 to the power x ln 2 integral of this, right? Now this 2 to the power x is equal 2 to the power x is equal to t cube plus 1, right? So this thing I can write as 3 upon ln 2 goes out of the integral t cube dt. 2 to the power x is t cube plus 1, right? So this is t cube plus 1. And what are the limits of t? Okay, so this was the change of variable. X is going from 1 to log of base to 9, right? So if x is 1, t cube is 1, right? So t is 1, right? And if x is log base to 9, this is going to be 9 minus 1, 8. So t cube is equal to 8, so t is equal to 2, right? So the limit for t here is from 1 to 2. Okay. Now this is the integral. So this was this part of the integral, right? This thing here is this thing. Okay. Now let's see the second one. Second one also, I can write this thing here, this integral here is the same as integral 1 to 2 log 2. I'm just changing for x, I am writing just it to be t, that's all. So now see, this thing is here and this is the first integral here. This part 1, this integral was part 2, okay? The answer is going to be 1 plus 2. This thing here is part 2, right? So now we have a property, if you remember, if there is a function fx, okay? If I have to find integral of that function fx dot dx. So this is in general I'm telling you. So if I use integration by parts, 1 dot fx I can write this as. Using integration by parts I can write it to be x fx minus integral of x f dash x dx, right? So from here if you rearrange, I get this property, okay? I'm writing the property here. This side I'll take this side, okay? So that will give me integral of fx dx plus integral of f dash x is equal to x times fx, okay? So I end up with this property here. I am going to use this property. So this thing I'll say as ft, let's say, okay? ft is this thing here, okay? Now see, I will apply this property for the function ft here, okay? So this thing here, part 1 is integral of ft dt, right? From limits 1 to 2 for t, okay? Plus, what is this thing? If you see this thing here, f dash x is how much? Let's find out f dash t. If this is the function ft, f dash t can be written as 1 upon t cube plus 1 into 3t square, and since the base is 2, there will be 1 ln 2 in the denominator. So now you see the part 2 here. This thing here is nothing but f dash t is equal to 1 upon t cube plus 1 into 3t square, and since the base was 2, I will write 1 ln 2 here, okay? So this is f dash t, right? Now the part 2, this thing here, that we have to find out. This is nothing but, if you see, 3t square upon ln 2 times t cube plus 1 times t. Okay, so this was f dash t and times t, that will make it t cube. Okay, so that is nothing but part 2. Okay, this is integral, the limits are also the same from 1 to 2, right, from 1 to 2. And by using this property here, I can say this is equal to t into ft. What was my ft? This is the ft, right? So this is t times ft for the limit 1 to 2. Okay, so that will give you 2 times log base 2 9 minus, for 1 this is going to be 1. 2 log base 2 9 minus 1. So that is going to be the answer. Now this 2 log 2 9 minus 1 is approximately equal to 5.33. Okay, this is approximately equal to 5.33. So the greatest integer of this is going to be 5. So 5 becomes my answer for this question. Okay, thank you.